So next is we'll see how we can construct B tree. That is how we can carry out insertion process in B trees. So as we all know, B trees are different from binary trees and binary search tree. So in binary search tree or binary tree, we'll be having maximum 2 children for the node, root node. But here uh, it is not the case. Based on the order, you can have children, and the key values we are going to insert will be m minus 1. That is, if the order is 4, you can have uh, m minus 1. That is 3 keys you can hold in a node. So that is the case here. So, so in this B tree, for example, so here this is an example of B tree of order 4. Here M is 4. So it contains maximum of 3 key values. Okay, 3 key values in a node and maximum of 4 children. If M is 4, we can have 3 key values in a node and maximum of 4 children for a node is possible here. And just see this diagram, see the tree construction. 30, 70 are the values, key values, data. So these 8, 25 are children of 30, 70, and 40, 50, 76, 88. So these are all children for 30 and 70. And for 1, 3, 7, 15, 21, 23. So these are all children for 8, 25 node. Okay. So this way we are going to construct the binary B trees. So next is insertion operation. So how we are going to perform insertion operation? We'll see the steps here. So in a B tree, a new element must be added only at the leaf node. Okay, so that means the new key value is always attached to the leaf node only, not the root node. So the insertion operation is performed as follows. Step 1, check whether tree is empty or not. And if the tree is empty, then create a new node with a new key value and insert it into the tree as a root node. Okay. So if the tree is empty, you are going to create a new node with a new key value. Okay. And insert it into the tree as a root node. If tree is not empty, if it is not empty, then find the suitable leaf node. We have to find the suitable leaf node to which the new key value is to be added using binary tree logic only. So what is the binary tree logic? The inserting the data we are going to insert. If it is less than the root node, we are going to insert it in the right hand side, or else we have to traverse to the if the data which we are going to insert will be less than the root node, we are going to traverse in the left side or else in the right side. The same logic is applied here also. That's what it's given binary search tree logic. If that leaf node has empty positions, you can add the new key value there, or else to that leaf node in ascending order of the key value within the node. So you have to follow the ascending order. Okay, so based on that order only, we are going to insert the new key value in the given empty position. So if that leaf node is already full, what we have to do here, a process happens that is nothing but split occurs at the leaf node. So once a split occurs, we have to send that middle value to the root node. So here the middle value will act as a root node, or else we can just swap or send that middle value to the root node. So it will be in the root node. So this will be repeated until repeat the same until the sending value is fixed into a node. Okay. So we have to insert, we have to see to that as it should be, your data will be in an ascending order in the node, and then if the particular node is full, what we have to do, we have to split that node and we have to bring that data to the root node, middle data to the root node. So these are all the steps we need to follow while doing insertion operation in B trees. So we'll see an example. Here if the splitting is performed at root node, then the middle value becomes your root node as I told you for the tree, and height of the tree is increased by 1. So here this is an example for the construction of B tree of order 3, that is m value is 3 by inserting new numbers from 1 to 10. So first I am going to insert value 1 here. So we are going to create a node and we are going to insert the value 1. So here the order is 3. Okay, so you can have 3 children, but a node must have only 2 key values. Okay, so that we must be clear. So this is my new node. I have created 2 values you can insert. So first value is 1, I have inserted here. And next is uh, uh, I have to insert element 2. So here after 1 itself I have an empty space. I am going to insert the second value 2 here. Okay, so now I'm going to insert 3. So what happens? Already I'm having 1 and 2. As per the order, my data is full here now. Okay, completely it is filled in the node. A node can hold only 2 in this case. So it is holding 2 values. So I cannot insert 3 here, new value 3. So at this case, what happens? Split occurs. So here 1, 2, 3. The data must be arranged in ascending order, correct? So here a split occurs at middle term. 1, 2, 3. So the middle term is 2. Correct? Middle term is 2. So split occurs here. What happens? 2 will be my root node, becomes my root node. 1 and 3 will be the left and right child, because 1 is less than 2 and 3 is less than 3 is greater than 2. So I am placing it in right hand side. Okay. So this way we are going to process the data. So next is I'm going to insert 4. The same way 4 initially I compare with the root node. It is greater than 2. So obviously right hand side. So right hand side there is an empty space, right? After 3 there is an empty space. So I am inserting 4 after 3. Next is 5. If I am going to insert 5, what happens? 5 is greater than 2. So obviously my data will be in right hand side of 2. So I'm just placing this 5 here, but unfortunately I can't place 5 here because already my node is full, 3 and 4, because 2 data are already present. So what happens? A split occurs here. So 3, 4, 5. Now the middle term is 4. I am going to send this 4 to the root node. So 4 is going to the acting as a root node now. Okay, becomes root now. So I'm going to create a new node for 5, because why? Because this 4 is, so this 4 becomes my root node. 5 is greater than my 4, so obviously 5 comes right hand side of 4. So I have to create a node and I have to place 5 in the right hand side of the 4. So this way we have to insert data in the B trees. So once the node is full, it reaches its what do you call the limit, we have the split occurs. So obviously the middle term will go to the root node, and accordingly we have to arrange the data. So this process continues once till you insert all the values. Okay, thank you.